Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Today we will study a very important rule in differentiation. It's called the chain rule. And this rule will help us to find the derivative of composite functions. So if we have a function y equals f of u, means it's a function of the variable u. And u is a function of x, u equals g of x. Then dy by dx equals to dy by du multiplied by du by dx. So the derivative of y with respect to x equals to the derivative of y with respect to the variable u multiplied by the derivative of the function u with respect to the variable x, where dy by du is evaluated at u equals g of x. As an example, let's find the derivative of the function y equals 3x squared plus 1 in a bracket, and this bracket is squared. Here we have y, a composite function. So if we assume that the function u, which is a function of x, as u equals g of x equals to the term inside the bracket, 3x squared plus 1, the expression inside the bracket, 3x squared plus 1. Then we can write u as a function of, we can write y as a function of u. So y equals f of u, which is u squared. So instead of this expression in the bracket, we replace it by a function u. So y can be as u squared. So in order to find dy by dx, you have to find dy by du and multiply it by du by dx. So if you differentiate y with respect to u, you will get 2u. And if you differentiate u with respect to x, you will get 3x, you will get 6x, just 6x, okay? So if you multiply these two derivatives, which is the 2 times u times 6x, and then replace back u by 3x squared plus 1, then you will get 2 multiplied by 3x squared plus 1 multiplied by 6x. If you multiply out the brackets, then you will get 36x to the power of 3 plus 12x. Okay. This is here as another way of finding the derivative without using the chain rule. If you expand this bracket, means if you multiply this bracket by itself, you will get this expression, which is 9x to the power of 4 plus 6x squared plus 1. If you differentiate now y with respect to x, you will get the same answer, that is 36x to the power of 3 plus 12x. Okay. Another example here is an application in physics. An object moves along the x-axis so that its position at any time t greater than or equals 0 is given by this function, x of t equals cosine t squared plus 1. Find the velocity of the object as a function of time t. Well, we know that the velocity is defined as dx by dt, because the derivative of the position function with respect to t is the instantaneous velocity, or shortly the velocity of the object. So in this instance, x is a composite function. So we can write x as cosine u, where u is the term inside the bracket t squared plus 1. So to find the derivative of x with respect to t, first you have to differentiate x with respect to u and differentiate u with respect to t and multiply out these two differentiations. So dx by du will be minus sine u, and du by dt is 2t. So, and then you multiply these two derivatives, which becomes 2t multiplied by negative sine u. And then replace u again by t squared plus 1. Then the final answer will be minus 2t multiplied by sine t squared plus 1. So we solve the question by using the chain rule. Here we have a rule called outside-inside rule. It's the same as the chain rule, but in a very quick manner. So let's say if y is a function of g, which is a function of x, we write like this: y equals f of g of x. Then dy by dx equals the derivative of the function f multiplied by the derivative of the function g. Okay? So in other words, differentiate the outside function f and evaluate it at the inside function g of x left alone. Then multiply by the derivative of the inside function. As an example, let's differentiate sine x squared plus x. So x squared plus x is in a bracket, okay? We need to differentiate this function with respect to x. So what you do is, you say, what is the derivative of the sine function? It's cosine function. So the derivative of this function, sine x squared plus x, will be cosine x squared plus x. This is the derivative of the outside function, and you have to multiply this by the derivative of the inside function. So this term inside, the sine, we call it the inside function. And sine itself is the outside function. So the derivative of the sine is cosine, you can see here, multiplied by the derivative of x squared plus x, which is 2x plus 1. So the final answer will be 2x plus 1 in a bracket multiplied by the cosine of x squared plus x. Next, we have repeated use of the chain rule. Sometimes we need to use the chain rule maybe more than one time. So as an example, let's find the derivative of this function g of t equals tan 5 minus sine 2t. Okay? Notice here that the tangent is a function of 5 minus sine 2t, whereas the sine is a function of 2t, which is itself a function of t. Therefore, by the chain rule, the g prime, the g prime, or the derivative of the g function is, let's say they use the outside-inside rule. So the derivative of tan is secant squared. The derivative of tan is secant squared, but we write secant squared the whole term inside the tan function, which is 5 minus 2 sine 2t, multiplied by the derivative of the inside term, which is 5 minus sine 2t. Okay, so we have to find the derivative of this term, which is inside term, we call it, or inside function. Now, the derivative of this term, 5 minus sine 2t, will be the derivative of 5 is 0, and minus the derivative of sine 2t. Again, the sine function has a derivative of cosine, and we have to multiply by the inside term. So it will be minus cosine 2t multiplied by the derivative of 2t, and the derivative of 2t is 2. So the final answer will be secant squared 5 minus sine 2t multiplied by minus cosine 2t multiplied by 2. And we can rearrange this answer, and we got the final answer as minus 2 multiplied by cosine 2t multiplied by secant squared 5 minus sine 2t. Example number 5. The power chain rule simplifies computing the derivative of a power of an expression. And here you will realize the importance of the power or the chain rule. Let's differentiate this function, which is 5x to the power 3 minus x to the power of 4 to the power of 7. If we want to differentiate this function by expanding the bracket means we have to multiply this bracket by itself 7 times, which will be a very tedious procedure and will take a long time from us. So it's easy for us to use the chain rule, outside, inside. So we differentiate the outside. So this bracket, assume it as a function u, let's say, okay? So if we say this function is u, the term in the bracket, 5x to the power 3 minus x to the power 4, if we assume it's equivalent to u, then we have to differentiate u to the power 7 multiplied by the derivative of the u function. So the derivative of the outside is 7 multiplied by the term in the bracket to the power of 6 multiplied by the derivative of the inside function, which is the derivative of 5x to the power of 3 minus x to the power of 4. And then this function has a differentiation of 5 times 3x squared minus 4x to the power of 3. And then you just need to rearrange the terms by multiplying 5 and the 3, will get 15, okay? Now, the next part of the question, part B, we need to differentiate 1 over 3x minus 2. So 1 divided by 3x minus 2, we can write it as 3x minus 2 to the power of minus half. And the derivative of this term is the outside will have a derivative of minus 1 in front of the bracket. And this is the bracket, 3x minus 2 to the power of minus 2 now. Because minus 1 is minus 2, multiplied by the derivative of the inside function, and its derivative is 3. So the final answer will be minus 3 divided by 3x minus 2 to the power of 2. Part C here is the derivative of sine to the power of 5x. Again, we'll use the outside inside. It becomes 5 sine to the power of 4x multiplied by the derivative of the inside, which is sine x. And the derivative of sine x is cosine x. So the final answer will be 5 multiplied by sine to the power of 4x cosine x. Now the next example is show that the slope of every line tangent to the curve y equals 1 over 1 minus 2x to the power of 3 is positive. So to find the slope and to show that the slope is always positive, the slope is equivalent, the slope of the line tangent is equivalent to the derivative of the function. So first we have to find the derivative of the function, and we prove or show that the derivative of the function is always a positive term. So the derivative of this function will be the derivative of 1 minus 2x to the power of minus 3. Again, we will use the outside inside. Hence, the derivative will be minus 3 multiplied by this bracket to the power of minus 4 multiplied by the derivative of 1 minus 2x. 1 minus 2x is the inside function, and its derivative is minus 2. So the final answer will be 6 divided by 1 minus 2x to the power of 4. At any point with the coordinates x and y on the curve, provided that x is not equivalent to half, the slope of the tangent line will be always positive. Why? Because 6 is a positive number, and the denominator here is raised to the power of 4. So any number raised to the power of 4 will be a positive number. So here, if you divide positive number by positive number, the answer will be a positive number. Okay? So this is true for all values of x, except that x equals half, because when x equals half, the denominator will be 0, and this will be an undefined number. Okay? Here we have some exercises from your textbook, and we will discuss these questions in our class. Here we have 3 sets of questions, so we'll be discussing these questions in our class. Okay, so until I'll see you during the class, take care of yourself. Bye bye. Assalamu alaikum.